better to, okay, go back to your sharing because we got some record, and if necessary, I can send it to you or I can review your performance from time. That can go, yeah, go back. Okay, so let's move forward. So this is just, you know the purpose now. The purpose to introduce a matrix here is in order to describe the score, okay? It's of course, if you don't use matrices here, you can still manage it by use a table, okay? But by introduce a 4x4 matrix here, then we can easily work out the total accumulated score, okay? In this case, you can see this is product. So this means a product. So when you see this is similar to all, let's just go to, when you study matrices, you have this similar. They can compare with what is formula in algebra. So when you see the x, if you say the x squared in algebra, and you know that you can write it as x multiply x, right? Similarly, if you're dealing with matrix here, if you say the square, so what does it mean? It just means that the product of two matrices, okay? So in other words, these just represent two matrices, the product of two matrices. Of course, in order to work out the product, this is a product of the two matrices. Then we can follow the multiplication rules, okay? Can we go down a little bit? I can only say part of that. Can we just go to the, okay, let's just go there. This time, let's do something. Let's clean this first. Okay. Now this time, see, that is how, can you see? The formula for the score is the same. Do you agree? But if you want to notice the second law, you can use the score. Can we just call the this is how to incorporate information. Can we just use A? It's just store more information. Can we use this score A that round 2? That's how I record it, okay? Now, before we go further, can we just work out the formula for this one? If you have this 4x4, okay? So the A11, can we call this M? Let's just say that. I'm going to show you, no, let's just go to 2x2, okay? So A11, A12, A21, and A22. Multiply, in this case, multiply different metrics. That is B11, B12, B21, and B22. Can you work out the product? This time we just use notation. We don't use numbers. That will help you to keep the track of what are you doing. Good. Okay. So what I mean is that this will be the C. Can we call this C? If we just undo that. So if I call this a C, matrix C, that's the C11, C12, C21, and C22. Okay. What is the formula for Cij? In the form of sigma. It's very important notation in mathematics. How to generate this formula in the form of the sigma? In sigma form. If you watch it here, so which is variable in these two elements? This is 1, 1, 1. Can you see this 1, 1? Plus, which number is varied? Which is keeps constant?
They both
Yeah.
change. It's
Yeah.
just
This is 2. Can you see? This is 2. This is 2. Can you see?
yeah, but it's different places.
Yes, that's right. So how can we describe this situation? Can we use our knowledge here? So before that, how can we describe the product, which is, for example, you have A and B. Can we, how to describe the first term? Perhaps before we use the sum, we can just rewrite this clearly. Can we just pick up this one? Just pick up this one. This is our C11. Can you see that? This element is C11. Do you agree?
Yeah.
That will be equal to the sum. I just copy that. It says 1, 1. Okay. I put a different color. 1, 1. And then what is that? The B1. Okay. So B1, can we put this 1 here? Another is, I use different color then. So this actually move, this is changing. Okay. This 1. Yeah. So then how about the second term? We got A1, 2, can you see? And B, what is B? B2, 1, can you see? So in this case, the variable, the integer increment by 1. This is a 2 and a 2. Can you see that? Now, can you try to fix this formula first before we go further?
I think you got it the wrong way.
Yeah.
B. It should be B21.
Let me see. So this is a A11. So A11, B11, okay? And then plus A12, A12 multiply B21, okay? B21. Oh, this is wrong. Okay, this is 2, 1. 2 is here. Okay, 2 is here. 2 is the other way wrong. Okay, you are right. Yeah. So can I to put the B in front? That'd be better. Yeah. That'd be B1, and the red color is variable. Can you see? Variable. Now, can you try to rewrite that as a sigma form? We do it one by one. This found is a formula for C11 first. Certainly, we involved 2, A and B, right? Can you just write the name of element and then put the subscript? Then we found the subscript. Can we put A and B first? It is a product, isn't it? Every term is a product of A and B, but the subscript must be fixed. Yeah, A1. Use K, yeah, good. K represent integer. Very good, very good. You learned something new today? This is very important step. Okay, probably at the school the teacher didn't teach this at this stage. All right. If you know, this is in mathematics. There are 2 types of mathematics. One is called discrete mathematics, in which the variable is step by step, is integers. Okay. Another type of the mathematics is called continuous. So when we started quadratic function, we will start exponential function or logarithm, where the variable is changed continuously. Do you agree? All real number accepted. One moment, I put my little bit of code. Okay, after you fix this formula, can we jump to here? Can we work out the formula for the general formula here? Can we try to work out this formula? Yeah, this is all right. So this formula is good. This formula is correct. Are you waiting? What are you waiting for?
Um, can I try writing the other ones first? Just to
Which
see.
one? Which one? You want another C, right? Yeah, okay, you put another one. 1, 2, yeah. C12. I know can we C12? This is C12, right? Good, good. Yeah. So the K is variable. Can you see? K is variable. It changes step by step. Okay, that's correct. That's correct. Okay, can you jump to the general formula now? Yes. Okay. So what is the common? I just draw your attention. You see, what is the common in this expression? So the first one is unchanged. Can you see? If I draw your attention, this K is variable. At the end of these two is unchanged. Can you see that? Okay. In other words, can you see another way? So this one, oh, it's too thick. I just want to draw your attention. Can you see this one is associated with this one? Can you see? It would appear. Can you see? And another one is here. Can you see? At both ends. Can you see the? Can you see the pattern now? When you study mathematics, you are looking for pattern. Okay. So this is a very good exercise to doing the pattern exercise. How do we organize this formula in a more compact form? You do have A and B. What are you waiting for? We do have A and B, isn't it? We do have A and B, can you see? We do have A and B. So you put the element name first, then put their subscript. You know, this is called a subscript. Okay, go on. Yeah, you have done that. When you write can you see? When you write a matrices, you put a subscript in at this corner, okay? This is called a subscript. Subscript. Can you see this is this? What? How about this? By the way, if this, how about this one? How about this corner? What do we call this? What do you call this position? Superscript. Yeah, superscript. Yeah. Anything else? Where is the element B? No C. You can in this subscript. If you think this also, you can either use the number. Okay, you can either use the number, or you can use IG, or you can use say you can use a 2G. Okay, there's no C. C is the name. So this is C. This is X. Can you see? That is X. That is a major element. The name of element. Are you studying chemistry? Do you know this one? If we have, say, this is, do you know this one? We put a number here at other superscript. Do you know this notation here? Sorry, not 4 by.
Yes, it's like
Can you?
atomic number, mass number.
Yep, it's a mass number. That's an atomic number. Do you agree? You see, you understand now. When you study science, the four corner can be used. Okay, do you understand?
No.
Sometimes in this case, one corner can write two numbers. That's how we denote a variable in mathematics. I give you a story, okay? I know you're a good learner. Can you just say, for example, a flower? Can you see this is as how to a flower from South Africa? How do we denote that? Flower. okay, from South Africa. Can you see? Okay. In the first month, the first month, okay. That's how you write, how to write a sentence in mathematics notation.
Yeah.
Okay, okay, go on. What you're waiting? Why don't we got a B here? Why you're waiting for? You got A and a B. Can we just
Yeah,
fix this?
understood.
Yeah, okay. Very good, correct. Then you have to tell people how does K change step by step, and from where, from beginning, from initial value to the what is initial value, what is the final value. Because so long as we know this integer, we know that each step is just the whole number, right? The interval is just one whole number or unit. Yep, good, all right. So this is something so it's boring. If you just study the dominant matrix, you wouldn't learn much because this is part of application now, okay? Now from here, can we go back? Now, can you look at this formula here? Can you give them a sigma notation to just work out these particular elements? Can you see? Where's it? How they got to 2? A, B, oh, this one, sorry, this one. This is A, B, can you see? This is A, B, can you see? So basically this is A, B, do you agree? Can you write a sigma formula for this sum? If you just remember this, can we use M? Each has M, same ij, similarly this mij. Okay, that is element. Do you need help? In this case, A and B are identical. This is much simpler.
Yeah.
A and B are identical.
So,
You can use M. Can we just use M for notation? Can we use an M for the element? Because this matrix is M. Okay, we can use M. We use M and M, 2M. That's all. Then we added the subscript. It's just like a new language, right? The compact language. That's called mathematics.
it's just the same terms.
There must be a free variable here. Can you just look at this beautiful? Can you see? This variable is just interconnected. Okay, just stay closer. You have you will learn the pattern here. Can you see I use a different color to highlight the difference. So here, if I use green, can you see? These two are outsider. Can you see? So that is how to write it. So this is wrong. This is wrong. You see?
So would it just be the same?
Yeah. What's the variable? I and J is the A is fixed. Can you see? A, if we just record A, can we just call it 1? Because A represents 1, 2, 3. Yes, that's right. This is general formula, but in this special, so how does a K change?
It's just, I'm a bit confused. So is it like this
Yeah,
equal to like one of these boxes?
yeah, one of these boxes, yes. They are identical.
So it's just, is that correct?
Yeah, but except it's a special case. It's A and yeah, that's IJ. That's correct. Yeah, that's correct. You could no, except this one. This is 4. This is 4. Can you see? 1, 2, 3, 4. Can you see? It's K equal to 1, K equal to 2, K equal to 3, and K equal to 4. Can you see?
Oh yeah.
Yeah. So actually, this formula is very useful. This formula can be extended to any dimension for the square matrix. Okay, you can go to n. Can you see? You can go to n. A can be any numbers. 2, 3, 4, 5, 6. Okay, that is notation. Now this diagram is different. This is nothing to do with matrices. Okay, this is just this actually introduction to what we call the graph theory. Okay. They try and use the graph to solve the problem. Okay, go on. Can you just go down? Do you want to save everything and move forward and clean up everything?
Could we go through the Leslie matrices?
Oh, that's different. That's different
Yeah.
matrices. Do
Like
you want to change the subject now? Yeah, this is another special matrix. You see, matrix. These are all part of education, not part of application of matrices. Okay. So this is just used to defend, a particular, these are groups population control, right? The population, they have the. Can you read? Do you know the scenario of this background?
No.
Can you see the keyword here? The discrete, okay? Can you see the keywords now? So in mathematics, one is discrete. In this case, we didn't use continuous variable. So basically, they are going to start the population change, okay? So the name of model is the subject. The subject is about population growth. So there are certain amount of the animals, okay? The animal have particular reason they have probably survived. They just like the game, you see, the animal can, if they are too old, they will die, okay? This basically, I think this just describe different group. I think that is, can we just read about this background? So it's just describe how the particular animals, they survive, or the birds they die, because basically the growth, the opposite. So can you see that? When we start the growth, the opposite is death, do you agree? So the animal could die. When they're getting old, they die. But during that time, they have baby. Do you understand? So that is the context where the matrix can help. That to help you to just seem like the game we discussed before. When we discuss the game, dominant game, and we just work out the total score. Okay. In this case, you can use this model to predict what would happen in many years later. Okay. So the objective is to construct the matrix so that we can use this matrix repeatedly for the first, for example, this is the first year. So the first year, right? Like this, can we call this N? Can we use this is can we use L? Can we use L for listening, right? Is L. And the second year, we know that it will be the second year, okay? And the third year, similar to the previous application, we're talking about the different round of the game. In that way, you can determine the particular number or population in different age group. Do you want to go to detail now?
Yep.
So this is called age group, okay? So this is just how to represent this age by numbers. Okay. Oh, they can live as long as 100 years. Is that right? Population. Oh yes, that is average. Yeah, average. So basically, because if we don't have time today, we will continue. Basically, what happens here is that if you have the age group, okay, so we can predict how the number of different age group change, given the condition that at different age group, okay, some group people just grow, others they have baby, okay. If you go to higher ages, so the chance to die is increased. Do you understand? So birth, death, and then growth, that is the model. What about? Then you have to talk about, can this base rate? No, not too fast. Can we just look at the definition? What is, how to describe the survival rate? If you want to learn, then you have to, so they have to start one, but what is survival rate? What is birth rate? How to define a survival rate? How to define it?
It says.
So they progress. Every year they grew up. They just grew up by 1 and plus, okay? They have interpretation. What is the sum? The rate. Oh, the rate is between 0 and 1. So they only have two choices, you agree? The survival rate of the last age group is taken to be 0. Okay, do you know why? So when the age increase, okay, the age, so the survival rate decrease, okay? If this is survive, so this is, how many age group do you need? 10, right? 1, 2, until 10, okay? So obviously the survival group of baby is 1, okay? It's got two choices, 0 and 1. Do you understand? But by the time getting older, then that surviving group that became 0. They have two choices. How many? They have only 2.
Wait, isn't it a range? I mean, yeah, like.
No, it is how many options you can choose. So how many state? I call it state of the living, state of life, right? If you call it.
It's between 0 and 1, but doesn't mean it doesn't say it has to be an integer.
Well, I think, yeah, or it didn't say it's change. Sorry, it's change. So it's probability. Rate is a probability. Okay, it's a chance. Can we say it's chance? It's continuous. In this case, this S is continuous. So therefore, yes, yes, they have certain. I'm wrong here. So this basically they have survival rate. So this says this is 100%. So this for the baby, that's probably as high as 99. All right. But for the people in this group, the surviving rate is slim, okay, probably 10%. And probably for the people who get to 100 years old, they're probably just 1%. Can you see that surviving rate change? Does it make sense? So if you want to draw the diagram, if you want to draw this graph, so basically for the baby is high, okay? And eventually they die down, can you see? And it's go to 0. That is survival rate. Let's go to birth rate. This is a small society, isn't it? It's a very small society. So if there's no migrants, there's no migration, so the total number keeps a constant, okay? And the total number will equal to the number added the newborn baby minus people who pass away. Can you follow me? So the birth rate for the age M is the average number of female offspring from a mother in the age group during the one time period. So what does that mean? What is one time period?
Like it's just the sudden time period that they record
Yeah,
the
at a
results.
certain age, yes, certain age. So you have to, yeah, this is a, well, that's the background, okay. Can we just go to simple group? This is general description. Can we just go to this simple example? If you go to a simple example, you should be able to understand this better. Can I just clean up this one? Okay, that's simple. They got a 3 age group, okay. With example, this 9 years, okay, that in this group, this particular group population, the particular animal, the 9 is oldest. Okay. So in other words, surviving rate for this particular group, like 3 is smaller, you see, than others. So you would expect that this element in this what you call the matrices here must be the percentages. Do you agree? Do you agree? So you will probably encounter this type of elements in your element. All right. Let's move forward. So this population, okay, that is a vector. Can you see this? Do you know how to do this? Vector. So this is special. This is all called a single column. The single column called a single column, right? Matrix. A single matrix. The single column matrix is actually a vector. Okay. Do you know how to derive how to denote the vector? A vector. How to derive the vector? Have you studied vector at school?
No.
No, not yet. Oh, I just need to. Yeah. Vector have the components. They got x, I, plus a,
Yeah.
y. Have you seen that?
Yes.
And that's just 2 by 2. Or you can write this as a matrix. It's called a single column matrix. You can use x component here and the y component here. Okay.
Yep.
So that is very useful. In we study mathematics, we also study other subject, say chemistry. We can use a single column to represent a state. In this case, that's the initial population, you see. So in this case, just clean all this. So this P is called the initial population. Initial population. Okay, so they have equally distributed group, 400 for no reason. And then things were getting changed. And then you have to put this corresponding birth rate. This is a rate, this is B for birth, S for survive, okay? That is how they constructed the 3 by 3 matrices. So each time, and in a particular group, they will have the newborn baby. They have birth. They could have birth or could have, but when the age increase, and some population will, pass away.
What is the survival rate for B3?
Survival rate is what's the challenge? What's the challenge? You're still alive. Yeah. That's called the surviving rate.
Yeah, but like, would survival rate be here?
Or if you're 4 by 4, if you're 4 by 4, so if you're not sure what you can just do some trial, okay? Because this is a little bit abstract. If you don't start it, you see, I think that next time we'll start some basic knowledge, okay? Like we did today. We have at least have to know what is this method, transpose, okay? Do you have the conjugate? Do you see the complex number? You have to see the conjugate. This is called the conjugate matrices. That will include complex number you mentioned in your test, okay? So yeah. The 2 matrices here today is just the application to use matrices. Now, if you want to work out the population next one, the can we put the population 1? What is the formula for this one? If we know the formula, if you know the Nestle formula, that will allow you to predict the population from the initial condition. So that is how to do it. This is a matrix form. If you write it more explicitly, then what we have is that we got, therefore, how can we do the calculation? After do the calculation, you know how to, what is L? What is L? Can we choose 3 by 3 or make it larger? 3 by 3, right? 3 by 3, yeah. Can we use 3 by 3? Make it larger. Okay. Can you copy that? Can you copy this one? They got number. Can you copy this one? They got number. No. Copy this one. Yeah, copy this one. But this definition, you have to compare with these two, all right? One is definition. You know, it take a while for people for students to understand what that mean. But today, we just get familiar with the purpose of introducing this listening matrix, okay? Now, in this way, can you use the product rule to work out the sum, to work out the product? Do you have enough space? If not, can you just move here? If it be too crowded, can you just move here? Can you move your can you move here? Yeah, we can use this space here. Or we can use this space. Okay, that's better. Can you use this space? Can you use this space? What do you think? Sometimes we can use your textbook. Do you agree? If you use your textbook, we don't have copy a lot of the stuff here. Oh, still you're too crowded. Yeah, nearly. Yep, you can probably we just work out this example. Oh, can we just work out the result here? It's still by, is this just a single column? Do you agree? This will be the single column matrix or a vector. Do you agree? Multiplication of matrix with a vector will give you another vector. That is the key. Oh, amazing. The number increase. The group 1 increase. Obviously, do you know why the group 1 increase?
Well, high survival rate.
Well, they are younger, they are babies, okay? They are kids, okay?
Oh, yeah.
Simple, right? It's just different age group. Of course, the group 3 will decrease, not surprising. But this is the first year, okay? Each year, you can use this listening matrix to calculate, okay? Can you see that? Yeah, if you know the role of the product, then you should be able to work out this. But importance, you must learn the ideas, okay? Today, we have learned 2 different matrices, which has applied into different situations or scenarios. And they have something in common. That is that we can predict what's going on in the next year. Can you see? Many years. If you continue to this product, we can do it for in principle. If that rate keeps the pattern, if the pattern of the surviving and the pattern of the birth, the pattern of death, birth, keep the same thing. So what we can do eventually. So for example, can you answer me this question, if you could? What would be the population in the nth years? How to write this formula for the population in the nth year, knowing that we can use the product to predict consecutive years? Yes, that's right. That's right. Yes. Okay. Can you continue? Can you write it continuously? Can you just keep writing? Yes. What is next? What's the Pn equal to 1? What's the Pn equal to 1? Can you just find somewhere to write? Yeah. Okay. I give you a hint, okay? That would be equal to L multiply Pn minus 2. Do you agree?
Yeah.
In other words, that would be equal to L squared. Can you see that?
Yeah.
Okay, can you continue? We just continue. What would be, how to rewrite the Pn minus 2? So this L squared, how to rewrite the Pn minus 2 in terms of previous years, previous years, okay?
You wrote cubed already.
Yeah. Yeah, minus 3, yes. Oh, yes, good. Yeah, you can see the pattern. Can you see the pattern show up? Can you see?
Yeah.
The pattern show up. So what would be, can I just stop here? Yeah, you can go to another trial. Okay, can we stop? Can you see the pattern now before we go?
I see.
I draw the highlight as a pattern. So when you study mathematics, you must know how to find the pattern. Can you see this is 4? This is 4, this is 4. It's consistent. Can you see?
Yeah.
That's right. Now, finally, what will be the Ln after nth year? What will be this factor here? N minus n, do you agree? Can you simplify
Yeah.
this a little bit?
And
Yes, perfect. I think you have learned a lot today, do you agree? So be patient, sometimes be patient. We have to get some, we build the house, we must build the foundation in the first place, okay?
yeah.
Okay, we can continue our discussion next time, all right?
Yeah.
Okay, goodbye.
Thank you.
You're welcome.